We're going to take a brief look at adding and subtracting fractions. I'm going to keep this pretty simple, just doing a few examples just to kind of get you started in case it's been a little while. I imagine most of you are doing pretty well, but every now and then we need a little bit of a refresher. So first thing I want to remind you is that we have a couple of steps. First up, get a common denominator. I will mention if you're dealing with mixed numbers, you'll probably want to change them to improper first, potentially. But you'll want to get a common denominator. And then remember that we combine the top or the numerators and the bottom or denominator will stay the same. So it's really not too much to keep track of. We'll work our way through about 3 examples or so. And then, of course, simplify as needed at the end. Okay? So, starting off, first example, 1/5 plus 7/15. So when I look at this particular problem, I notice that my denominators do not match, and I need them to match first. And so I need to somehow get both of these to have the same number on the bottom for the denominator. And what I'm going to recognize is if I wanted to change this 5 into a 15, all I need to do is multiply by 3. So what I'm going to think about doing is multiplying the bottom by 3, but of course, whatever I do to the bottom, I have to do to the top. So when I multiply the top and bottom by 3, I'm going to end up with 3/15 plus the other fraction just comes straight down. Now when I look at these two fractions, I have the same number for the denominator, 15, which means I can add straight across. The top, 3 plus 7 gives me 10, and the bottom stays the same and I get 15. The last thing I want to take note of is if I can simplify my fraction, I want to. So I might be able to notice that both the top and the bottom have a multiple of 5 in it. So I can take that 5 out of the top and the bottom. And when I divide that 5 out, I get a simplified or best answer of 2/3. So the key to remember is both fractions need to have the same number on the bottom. And then when you go to combine, you only add the top or the numerators together and the bottom number will stay the same. Okay? Let's go ahead and take a look at another one. This time we'll subtract. So I'm going to put 3/4 minus 5/6. So a couple things changed. One, I'm subtracting. I'm going to treat it the same way as addition. And then the other detail I want to take note of is right now, I can't just multiply 4 by a number to get to 6. And 4 times 2 is already 8, and that's too big. Sometimes when you're getting a common denominator, you have to multiply both numbers by something, or both denominators to get something that's in common to both. There's a couple different strategies you can take. Sometimes you'll recognize a number that's bigger that both, in this case 4 and 6, go into. So for example, 12. 4 goes into 12 3 times, and 6 goes into 12 twice. If you ever can't see what that number is, you can always just multiply them by each other. I can multiply this fraction by 4/4, and I can multiply this fraction by 6/6. Your numbers may be a little bigger, you may have some extra simplifying at the end, but at least you can get going on your problem. However, I recognize that I can change the denominator to 12, so I'm going to do that. And in order to get 4 to become 12, I have to multiply by 3, top and bottom. And in order to get 6 to be 12, I have to multiply by 2, top and bottom. So whenever I do that, 3 times 3 gives me 9, 4 times 3 gives me 12, 5 times 2 gives me 10, and 6 times 2 gives me 12. Okay? So now I've got the same or equivalent fractions, just looks different. They have 12s on the bottom. And what I'm going to do is I'm going to follow my rules for adding and subtracting, which says that the denominator stays the same. It's just a 12. And the top, I subtract. 9 take away 10 gives me a -1. And even though you're not comfortable with it, maybe isn't what you're used to, it is possible to have negative fractions, and that's okay. So in this case, I would have a -1/12. last one we'll look at is the following. I'm going to throw in some mixed numbers. 2 and 1/6. Oops, sorry. 2 and 1/6 plus 3 and 1/8. Okay? So, first thing I'm going to do is I'm going to change these to improper fractions. You don't have to, but I tend to just kind of be consistent that way. It's easier for me to understand. So I'm going to go 6 times 2 is 12. 12 plus 1 is 13. So I have 13 over 6. And then here I'm going to go 8 times 3 is 24. 24 plus 1 gives me 25. All over 8. If you don't remember how we switched to improper, go back to the original fraction video. It should point that out for you. So now, just like we had in the previous example, I have two numbers that don't match for my denominator, and I need them to. And I need a number that both of these multiply to kind of get a common denominator. And I'm going to key in on that both of these numbers go into 24. 6 times 4 is 24. 8 times 3 is 24. And if you don't see it, that's okay. You don't always have to use the same thing. So I'm going to go times 4 times 4 and times 3 times 3. Okay? And so now I end up with the following. First fraction is going to be over 24. 13 times 4, let me think about that for a second. 4 times 10 would be 40. 4 times 3 would be 12. So 40 plus 12 would be 52. Over here, I'm going to have 24 on the bottom and 25 times 3. That's like adding 3/4. So that's going to be 75. So now I can add them up. On the bottom, I'm still just going to keep the 24. On the top, 5 and 2 gives me a 7. And the 7 and the 5 is going to add to give me 12. And then it becomes a question of if there's any numbers in common. I could try taking out a 2, but that's an odd number, so I can't take out a 2. I could try taking out a 3, but this number up here, 3 is not going to go into that, and 5 doesn't go into both of those, and I think that might be it. You could potentially turn this back into a mixed number if you wanted. You might also be able to leave it like this. If I wanted to turn this into a mixed number, all I'm going to do is divide 24 into 127. It doesn't go into 12 at all, but 24 will go into 127, and I believe 5 times. We'll find out. 5 times 4 gives me 20. 5 times 2 gives me 10 plus 2 is 12. So when I subtract, I would have a 7 left over. So I could leave it as an improper, or if I wanted to write it as a mixed number, I would have 5 as a whole number, and then I would have 2 7s. Sorry, just did that wrong. I'm going to have 5 as the whole number, but then my remainder of 7 is going to be over what I divided by 24. So I could have my answer as a mixed number, or I could have my answer as an improper fraction, and it just depends on what you're looking for on that particular problem.